My name is Yelitza Rojas, and today I have the pleasure of presenting the SIPROTEC Digital Twin. According to the prepared agenda, I'm going to start with a general introduction, then I'll present some use cases, and at the end, we'll have some time for discussion. So let's start with the general information. In any industry, we see roughly the same main drivers for daily and strategic decisions. Optimization of total cost of ownership, minimizing CapEx and OpEx necessities, efficiency, reduction of both the project execution times and availabilities, and improvement of the reliability of the system. The issue is that they normally don't play together. For example, if the reliability is to be increased, then normally a higher inversion is required. The digitalization is finally giving us some levers to steer all these drivers in the right direction at the same time. And one example of this is the digital twin. In many application areas, and especially in the production of goods, it has been increased the use of the so-called digital twins. A digital twin is a virtual copy that contains all the data and simulation models relevant to the original, where that original could be a product, a process, or even a complete system. The digital twin can be the shadow of the original during the whole life cycle and allows a complete validation and optimization of the performance before the actual phase takes place, being this engineering, testing, maintenance routines, and so on. And as a matter of fact, it is expected that digital twins become a trusted standard for testing and certifying technical solutions. I have added here in the slide the link in case you want to take a look at the document afterwards. So as you see, digital twins are a reality already, and we at Siemens Electrification and Automation have jumped into this virtual journey as well. Our innovative cloud-based SIPROTEC 5 Digital Twin is a real-time digital replica of a physical SIPROTEC 5 device, including interfaces, functionality, and algorithms, available for the user at any time from everywhere, following the highest cybersecurity standards. Digital Twin allows testing of the energy automation system with low effort and within minutes, without hardware, without wiring, without physical testing equipment. It is the companion of the SIPROTEC 5 device along the complete life cycle and can be used during the acquisition and design, implementation, commissioning, operation, knowledge transfer, maintenance, and service. You can validate, for example, if the response of the device corresponds to the premises used to create a configuration. You can discover in an early stage if the logic you planned is not bringing the results you expected, so it can be comfortably improved and updated. You get the configuration of the device exactly as you want to have it, and after that, then you start the replication for additional base, saving lots of effort in reconfiguration, which are inevitable when the errors are discovered just during the commissioning phase. The quality of the engineering improves, and the FAT and SAT times can be considerably reduced. Getting ready to start using the digital twin is truly simple. Only 5 steps are required. First, open your project in Dixie 5, then export the configuration using the SIM format. You can export one device, several devices, or the complete set of devices contained in the project. Log on in the cloud with your user account and password, then upload the SIM file that you exported from Dixie, and then go to the simulation. It is really simple. If you want to work on an existing device or project, then you will restart from the step 3. You skip the step 4 as the file was already uploaded and jump directly to the step 5, meaning only 2 small steps to continue working. So now let's see the capabilities of a digital twin in the fields of protection and automation. And the first one goes to the device itself, that is to the ID configuration, with its protection settings, protection algorithms, online debugging of user logics, test sequences can be used, and the download of event logs and fault records is enabled. However, the applicability of the digital twin is not limited to the device itself. The interaction of the device with other SIPROTEC 5 relays, as in the case of a line differential protection through the data protection interface, the communication with third-party devices through standard communication protocols as the GOOS part of the IC 61850, the connection to a SCADA system via IC 61850 or IC 104, DMP3, Modbus, Profinets, or even the integration to IoT ecosystems can be also tested with this digital twin. So let's take a closer look of the interface. On the left side, you can find the physical interfaces of the device as the analog and binary inputs. And on the right side, you find the device with its reactions in form of digital outputs and logs. The device gives you the same look and feel as if you'd have the real device in front of you, and you can interact with it using the menus and operation keys as in the physical device. In this way, you can test any SIPROTEC 5 device before ordering it. And if required, even the real and virtual worlds can come together for testing through a VPN network. So you can combine your existing testing lab with the extended capabilities of the virtualization. To make your testing experience even easier, several applications are already available as part of this cloud service. They are generally accessible to all users and licenses, with the exception of the demo licenses. This option is especially convenient for users with restricted administration rights in the local PC. You will find several applications for different use. Dixie5 and the system configurator for the parameterization of the devices and the IC 61850 communication, the web user interface for connection to the web server of the device, SIPROTEC tools for functional upgrades and hardware testing, ComTrade Viewer and SIGRA for fault analysis, depending on the user license, and additional tools like IC Browser, Wireshark, and Simple Values Capture for protocol testing. Additional features as the support of the SIG and PAS are also included. You can store the files import to be used in the remote applications, and also those files created in the virtual environment. You have available a persistent drive with 1 GB space, where the files are stored permanently. That means after a log off and log on, you will find information in the drive. A larger non-permanent disk space of up to 5 gigabits can be used during the user session. Under Projects, Files for Applications, you will find the list of files you have uploaded or created, and an indication of the user space in the permanent drive. As you see, the digital twin provides the environment to test devices themselves and their integration among them and with other devices and systems. So let me summarize the benefits of the digital twin. You can test energy automation systems within minutes without hardware and without additional effort. You achieve a more efficient engineering process, smooth installation, and cost-efficient commissioning phases. For intervention in operative systems, the extensive pre-testing ensures short outages and so higher system availability. And a faster and realistic fault analysis is granted. All this reducing significantly time and cost, with higher agility and flexibility. So now I'm going to present some use cases that can be interesting for you. Please note this is only a small set of the possibilities and that several cases can be combined in a single project. And the first and more typical one is the testing of protection functionality. The busbar protection is an excellent example. The availability of the proper secondary injection equipment, the device itself with all the required terminals, the wiring of currents, signals, and trips, all these topics cost time, space, effort, and money. The same tests and even more can be done in the virtual environment. No hardware is needed. All the required current channels are simulated for the injection, as you can see here. The connections are simulated with the virtual wiring, and even the response of the circuit breaker can also be simulated with help of a CFC logic in an extra device. The testing procedure can be reduced from days to just hours, thanks to the virtualization. The second use case is the extension of existing substation. In this case, the integration of new bays can be extensively tested thanks to the full replication of the existing substation. Without digital twin, on one side, it would be required to have such a gigantic setup to be able to test the new bays, and on the other side, we unlikely could get availability of the energized substation just to test the integration. With the digital twin, we can fully replicate the existing station and the new base as well. The system behaves as the real one, and the response of the combined system, that is existing plus station, can alert on possible failures in communication, wiring, or functionality. The corrections can be implemented to grant the exact expected behavior before going live in the substation. So in case of intervention in energized substations, you can extensively test with digital twin and minimize the outages. The next case is the IC61850 communication with third-party devices. With an existing setup, you can test the integration of new SIPROTEC 5 devices without having the physical device. You simulate the SIPROTEC 5 device in the digital twin, and using a VPN connection in your local PC, you integrate the virtual device into the physical existing network, for example, in your test lab. With this scheme, you can prove the communication, the good communication among IDs, and the reporting from the virtual device to the substation automation system and human-machine interface, either from Siemens or from other manufacturers. In a similar way, you can test the integration of a SIPROTEC 5 device to a SCADA system. The virtual device shall contain the required communication interfaces, and the configuration shall be done to support the required protocol, for example, DMP3 or IC104. Then, enabling the VPN connection, the virtual device will be able to communicate to the SCADA, report the binary and analog information, and receive and process commands sent from the master station. The next case is the fault analysis via record replay. With this option, the expert, either from customer or Siemens side, is able to see the response of the device, making the analysis easier and more effective. Two parties can also exchange FANDIs being in different locations and far away from the installation. The ComTrade file of the real device is retrieved and replayed virtually by mapping the analog and binary channels to the digital twin inputs. That is, the inputs of the device are not fed from the simulator, but from the ComTrade. Additionally, when the root case of the failure is found, and it is, for example, a wrong setting, this setting can be modified and the ComTrade can be newly replayed to make sure the changes are satisfactory before updating the parameters in the energized substation. This option has proved to solve problems much faster than in the past. The next use case is the support of maintenance in upgrade scenarios, where configuration or firmware update is needed in a protection device. Normally, the following steps are needed. Relevant device types need to be identified with the corresponding parameterization. Identical devices in hardware and functionality must be available, and testing of protection and functions with the new firmware must be run in the laboratory. These steps can be done virtually, granting a faster and successful handling in the physical device. So, before installing security or function updates, you can check the correct function with the identical device type and the field-specific parameterization conveniently on the computer. This saves time on site and increases overall system availability. Now we have the 24/7 training center where you can use this to improve the skills of the operation and maintenance personnel, which is required for effective handling, also having in mind your specific requirements. Training sessions can be organized in a virtual environment, so the trainer and participants can be in different locations. The trainees get the same look and feel they would have with the physical devices. Display pages, logs are all exactly the same. And you have access to all types of SIPROTEC 5 devices. So you have an excellent training center available to make possible for your people working with confidence and no extra pressure. And the last use case is the virtual hardware in the loop. So complex scenarios of protection are typically evaluated with hardware in the loop and with expensive real-time simulators. Using the virtualization with Digital Twin and standards like ComTrade and IC 61850, the core simulation environment is ready, simplifying the efforts and investment as well. And this option leads us to the future, which is not far away. Some testing equipment manufacturers, like Megger, are already working in the virtual injection of current and voltage and the virtual energization of binary inputs and transducers. In such a way, the complete conventional testing can be replicated in a virtual environment, which significantly simplifies and speeds up the process. This test procedure can be run in an early stage of the project, reducing the time pressure normally experienced during the commissioning and energization. So now some impressions from our customers, which are already working with the Digital Twin. The first one is regarding to the wide range of possibilities for testing, and as the customer said, he was able to perform all tests that he wanted. And the second one is more highlighting the improvements regarding footprint and time savings. As summary, the Digital Twin has the same capabilities of the physical device and allows the evaluation and optimization of the performance. Time and cost can be reduced in the different life cycles phases of the device. Current users are impressed and recognize the benefits, and in the future, thanks to the standardization, it should be possible to test the complete station with digital twins of several manufacturers. We have a trial version available that you can use 3 weeks long for free. So if you are interested, please contact Siemens sales responsible in your country.